right? So this is something that we would be using for the first exercise, wherein we would be covering the direct modeling exercise in the first session. Okay, so for that direct modeling exercise, I'd request you to do all of the settings. The things I have changed is snap types, snap modes, and grid modes. And the same has been mentioned in your training guides as well. The next thing I would like you all to change is the visual style. So you can change visual styles from a variety of options. You can change it from the properties dialog box that you can see over here. So you can change it from mechanical to 2D wireframe. You can do that. Or you can simply right click on over here, okay, on the UCS and go to visual styles, and you can change it over from here also. So that's another way wherein you can do that. Or you can go to Drawing Explorer. So you can type in Explorer or the Visual Styles command. You go to Visual Styles and you can change the current visual style from over here as well. So there are a variety of ways in which you can make changes to the visual styles. Okay. So you can do that. Now for this particular exercise, in the initial, I'll be changing it to 2D wireframe. As I mentioned, you can do it from whichever way possible. So you can just go over here and change it to 2D wireframe. So whichever way it's fine. And then I'll just go to the top view. Okay, so this is my top view. I just clicked at the center of this particular UCS and it took me the top view. And this is my X and Y axis. And now I can start sketching. Okay, so the first thing that I need to do is create a polyline as mentioned in the training guide. So I'll use P line. That's the polyline I want to create. And once I click on it, I'll be able to draw or start a polyline. Now I'll be starting it from 0, 0, 0. I can simply put it on the X and Y axis over here. So it allows me to start it from 0, 0. Or if I want to be 100% sure, I can simply enter the coordinates as well, like I'm doing it over here in the command. So you can do that, and it would start the polyline from 0, 0, 0. And the first one, the distance is 200. So that is the first part. The next one, I'd be drawing it vertically upwards in the Y direction. So that's 100 for me. Okay. The next part is something a bit tricky, but not that difficult, wherein I had to draw a line at an angle of 135 with a distance of 70.71. So first, what I would do in this case is set the angle. Okay, so I can press tab to toggle between the inputs. So in case if you are not able to see the dimensions that I'm entering dynamically, make sure your DYN, that's dynamic input, is on. Okay. If it's off, you'll not be able to see the dynamic inputs that I'm giving right now. But if it's on, you'll be able to see this and you'll be able to do the same way like I'm doing on the screen. Okay. So I just locked the angle at 135. And now I'm just, since my snap mode is on, I just hover onto the grid. Now this distance is 70.71, which is what I need as per my training guide. And click over here and then you're good. Okay. The next distance is 100 horizontal. So I just click again over here. And the same 135 with 70.71 min. Again on the left hand side. And the next thing, I have to close this particular polyline. Now, this is something that I can do it manually, or I can ask the software to do it for me using this close command. So as soon as I click on this, or type in C, enter, or do it manually, any which way it would work. So I just click on over here in the command line, okay, close, and it would close the polyline. Now my sketch is completely ready. Okay. So before moving on to the next step, I'll just change the snap mode to 0 because this is no longer needed. I'll again change the grid mode to 0. This is no longer needed as well. And I'll change the visual styles to mechanical. So I can do it from the properties panel, or simply this time around, I'll type in the command visual styles and I'll change it to mechanical. Okay, and I'll close it, and now into my mechanical visual style. I'll change the view to top front left, or you can select any which view that suits you fine. So I'll just click on top front left from over here and to my top front left view. Okay. So the next thing that I want to make you all aware of is the selection process. Yeah. So make sure your selection of edges, your selection of places, and the boundary detection are all enabled, because these three options would help us in making better selections and accurate selections. So in case if they are off, they would not be highlighted. But in case if you want to switch it on, just make sure you switch it on and they would be highlighted on top. So this is for edges, this is for faces, and this is for enabling the boundary detection. So this is something we'll be looking at on a later stage. Okay. Now the next thing that we'll be doing is extruding our sketch. Okay. So giving it a Z dimension, wherein we'll be turning it into from 2D to 3D. So extrude can be done again in multiple ways, wherein I can go to solid and I can select this extrude command and do the extrusion, wherein it's asking me to select the extrusion entity or the sketch that I want to extrude. Or else I can simply use the chord window over here. Make sure this is on, the chord option in the status bar. Now, once the chord option is on, if you hover over the sketch, okay, you get n number of options that you can do inside this particular window. So you can create it into a sheet metal, or there are modeling options, or there are drawing options, modification options. So there are n number of commands or options that are available within the chord window. So you can simply select extrude from within it. So just to give you all know about of what chord is. So chord is basically a very interactive interface right at your mouse tips, wherein it even removes the thing to enter the commands. Okay, so you need not even enter the commands for you to be able to execute something. You simply can just hover over any entity wherein you want to do the changes or make any sort of extrusion of surface or extrusion of a solid or something similar. So chord would be very intelligent to understand the type of entity that you have selected, and it will give you options accordingly. So you can go to model and you can simply select extrude for this particular sketch. Okay, or the third part is wherein you can simply enter the command dm extrude and just hit enter, and then you'll be inside the extrusion command. So dm extrude is what we will be using for creating an extrusion. So multiple ways wherein, so the one way is choosing it from the ribbon, another way is using it from the chord, and the next way is using the command line. So any which way that suits you fine, you can use it. So for me, I'm accustomed to chord. So from now I'd be using chord a bit more, but in case if you do find any difficulties in facing or using chord, you can simply use the command line or also the ribbon bar. So that is up to you. So I'll just use an extrude, and I'll extrude it downwards at a distance of 20. Okay, I did not specify any angle at present. So I just extruded it at a distance of 20. And now I have my solid, the base solid ready. Okay, so this is the first step of my exercise, direct modeling exercise. Right. The next one, for the next one, and from here on, I would want you all to keep the dynamic UCS on. Okay. So for the next steps, we'll be sketching on the solid itself. Now for sketching on the solid itself, we'll be requiring DUCS. It can be toggled with the F6 key. Okay. So it can be toggled off or on with the F6 key, or you can simply click on the dynamic UCS button over here. Right. Now dynamic UCS, what it does is basically it would map the UCS onto any entity that I'm hovering my cursor. Okay, so basically just to give you a glimpse, let's say I'm creating a rectangular profile and I want to create a rectangular profile onto the plane or surface that is on the top. Okay, so as you can see, as soon as I'm moving my cursor on different surfaces or different planes, the dynamic UCS maps the actual UCS, the triad, accordingly. Okay, so as per my selection, it would map it accordingly. Now, this is the correct position of the dynamic UCS that I want to be. And I'll just make sure that I'll press shift to be able to. Okay, now before going to that step, what I need to do is simply select this body. Okay, you can select this body by pressing Control and click on it. Okay, just hold the Control key and click the body. Now, once you do that, you get the properties for the entire solids and just change the color to green. Okay, so before creating a rectangular profile, just make sure you change the color of your solid body to green. You can simply do that by selecting your solid body entirely and then go to its properties and change the color to green. So I can showcase it to you all once again. Just if you select now, if you see, I'm able to select only the faces or the edges, but just by holding down the Control key, and now if I hover over, it allows me to select the entire solid. So the entire solid is now selected, and now I can change the color to green or whatever color I want it to be. Okay. Also, the next step for the color in general, now whatever entities I draw from over here, just make sure it's changed to by block. Okay. Now this will allow me to see the entities more clearly when I draw it on the green part of the solid. Okay. So just make sure it is changed to by block, and now I can start drawing my rectangular file. So I'll just position my cursor onto this particular face, make sure the UCS is correctly aligned to what I want it to be, and then just shift lock. Okay, so I'll just lock it, and as soon as you press shift, the green face would get highlighted. That means now whenever I draw a sketch, I'm sure that it would just lie on this plane. It wouldn't go anywhere else. So that is what the shift locking would do. Okay, it will ensure that the sketch lies on the plane of your choice or whatever you have selected. The rectangle dimensions as given, the guide is 20 by 60. So just would enter the dimensions. So here is 20 and here is 60. Okay, so these are the rectangular dimensions that we'll be creating. And now, as in the training guide, we want this to get moved onto the center point. Okay, so the center point of this particular rectangle that we just drawn should be snapping onto the center point of this particular edge. So for that, we'll be using the move command. So just hit M, enter. So this is again a good thing about BricsCAD, wherein the 2D and the 3D workflows are integrated. So I'm moving a 2D entity with the help of a move command. So I just selected the entity that I want to move, hit enter, select the base point, the midpoint, okay, of this rectangular profile, and the midpoint of this particular edge. So I've moved my rectangular profile that I've created from this particular position to over here. Now, in case if you do not see the midpoint snaps, okay, which you could see on my screen, just make sure your e-snap settings are turned on. Okay. Now, when they're turned on, also make sure simply right click, go to settings. Also make sure that the endpoints, midpoint, center nodes are checked. Okay, so this would ensure that whenever you try to draw something or use anything as a reference, you'll be able to see the endpoint, midpoint, center node snaps. Okay, so I wanted to move this rectangular entity to this particular position, so I could see the midpoints of both my rectangular profile as well as the edge, which I was using as a reference. So in case if you're not able to see it, just make sure your e-snap is on, and even if it's on and you're still not able to see it, make sure your midpoint setting is on. Okay, so that would ensure that you'll be able to see the midpoints as well. Moving on to the next step, wherein I'd be extruding this rectangular profile at a vertical distance upwards by 150 mm. So again, we can use variety of different methods to be able to extrude it. I'll be using this time, let's say, okay, I'll just use it from the ribbon. So I'll just select the entities that I want to extrude, hit enter, and simply enter the distance. So I'll just enter 150, and I've extruded my rectangle profile. Okay, fine. So the next step is creating a circle. So C, enter is what would help us creating a circle. I can select the midpoint, snap to the midpoint, but in order to make sure that I draw onto the vertical face and not the horizontal surface over here, I'll just hover my cursor onto the vertical surface and press shift. So this locks the surface for me. My UCS is now locked. I can go to the midpoint and now start drawing a circle. Okay, you can either enter a 30 mm radius, or you can simply snap to the endpoint and you're good to go. So you can choose the method that you would want to create the circle with. So you can simply snap to the endpoint or simply enter the dimension of the circle. Both works well. Now, the next step that's there is extruding the circular profile by a distance of 130 mm perpendicularly away from the vertical stand. So this is extruding again, but perpendicularly away. Okay, so just move your direction away from the vertical stand and simply enter the dimension now 130 and hit enter. Should be able to extrude it. Okay. Now, one thing that we have inside BricsCAD Mechanical is a functionality called as design intent. Now, design intent helps us to create a set of rules, basically, or ask the software to be able to judge for us, okay? And in those scenarios, we'll be able to do the designs more efficiently, okay? Before that, we'll be just extruding this half circle profile to flush it at the end. So just select or hover over your half circle profile. As soon as you do that, okay, you'll be getting this particular option of extrude inside your chord, right? And as soon as you click on extrude, you can select till the end of this vertical stand and you'll be able to flush it right across till the end. In case if you're not able to see it or do it or select the face, make sure your face priority selection is turned on. So you have this face priority selections, which I showed you earlier. Make sure that this is switched on. And once you do that, you'll be able to select that particular face and you'll just be able to flush it across the end of the vertical stand, just like I've done over here. So the next thing is the design intent, which I was talking about earlier. So you can select the type of design intent that you would want from within the ribbon bar, or you can also use a command called as DM recognize and set it to a particular option to use the particular design intent of your choice. Now, what does design intent do? So to show the difference of what it does, first I would keep everything off. And now if I do a push pull for this particular cylinder, so BricsCAD does have a push-pull option as well, okay, which is not extrusion, it's separate. So if I click on push-pull, I'm able to change the width of this particular cylindrical profile. I'll hit escape. However, if we have done everything correctly, and if I choose this particular coincident planes design intent, now if I do a push-pull for this particular profile, you see the bottom part also gets modified according to what modification I'm doing to the top. So this is something that is possible, quite possible with design intent, wherein I'm asking the software to be able to intelligently work for me, right? So over here, the design intent that I've kept on is coincident planes. So what it basically does is it recognizes coincident planes, and whatever changes I make to this particular plane, the same change would happen to this particular plane as well. So I would suggest you to try this, wherein you can simply switch this on, and if you have done everything correctly, you'll be able to push pull it both together at one single point of time if you make changes to any of this. So you can push pull this as well, or you can push pull the top part as well. It will reflect onto the other plane as well. The next part is creating an offset circle onto this particular cylindrical profile. So I'll just hover my cursor onto this edge, circular edge, and very intelligently, the code will give me the option to create an offset. So I can directly select from within here, or I can go to draw and select an offset. So as I mentioned, the code is quite intelligent to show the commands which would be possible with that particular selected entity. So as soon as I hover my cursor onto this particular circular edge, it asks me to do an offset, or there are other commands that I can select from. So I'm just doing an offset. Okay, I just dive a bit inside and enter a distance of 10. Okay, so 10 is what I want to create an offset with, right? Now, this particular offset, I want to completely cut extrude through the entire cylindrical profile that's there. So for that, I'll simply hover my cursor onto this particular offsetted sketch that I just created. Okay, again, you can simply use the extrude command, or you can simply type in DM extrude as well to be able to cut the profile, circular profile from within the solid that's there. So I'll select the sketch, and once you do that, you can simply move outwards. So BricsCAD again is smart enough to understand that if I'm moving outwards, if there are no intersecting solids, it would create a new profile. However, if there are intersecting solids, it would just create a hole out of it, right? It wouldn't create another solid, just create a hole. But still, if I want to create a solid, I can simply select it from within here. So there are options for me, multiple options for me to be able to create or subtract or unite, or whichever, the lot of other options as well. So over here, I'll just do a subtract operation, wherein I'll simply add the distance. It could be any distance as long as it's cutting the entire profile. Okay, so I've very easily created a circular hole. Right? Okay. So the next step again includes a design intent step, wherein I can also recognize coaxial surfaces. So coaxial surfaces meaning surfaces with the same axis, right? So you can simply select this. And now if I want to move this particular cylinder on top, okay, or just change the position of it on top or bottom, I can do that simply by entering a command called as dm move. I'll hit enter, and dm move. With the help of that, I can select this particular surface. I want to be able to change the position of the outside surface of the cylinder. I'll hit enter. So the entities in the set, as you can see, are 1. I'll hit enter. And now the base point is what I can select anywhere. It could be the center of the cylinder, or it could be anywhere for that matter. And now if I move it upwards, across, or downwards, as you can see, the other portion, that's the whole portion of the cylinder, also moves with it, because the design intent of coaxial surfaces is found. Right? So in case if you are finding it difficult to be able to move or do a change that I'm showing, you just press shift. Okay, just hold your shift button, and now if you do it, you would be able to execute the same operation that I'm doing. With the help of shift, what we can do is we can lock the movement of the cursor to any particular axis. So right now I'm locking it to Y axis, but let's say if I leave the shift button, I can hover it anywhere. But if I still select, I keep pressing my shift button, I can simply lock it to the Y direction or X direction or Z direction. However, the changes would not occur in the rest of the two axes, but I can move it up and down in the Y direction. Okay, so this is the use of design intent. So I just request you all to try this out by yourself. The next thing that's there in the training guide is creation of fillets for these two edges. So over here, what I'll do is I'll select the edges. Okay, so you can create fillets for multiple selections. not a problem. And the command that you need to enter is DM fillet. Okay, fillet. The simple fillet won't work because that's for the 2D environment. You have to enter DM fillet. Okay, that's basically creating fillets for 3D. So simply enter DM fillet command, hit enter, and now give the fillet radiuses that you would want to have the fillet. So simply enter 25, hit enter to be able to create a fillet of radius 25. The next part includes creating of two circular holes on the base plate that's there. So for that, make sure your E-snap settings are on, and in the E-snap settings, your center snap setting is on. Okay, so make sure that this is check marked. And now I'll just enter C, enter, for me to be able to create a circle. And I want the circle that I'm creating to be concentric with the fillet that I've created, okay, the fillet arc. So I'll just hover over this arc, and as soon as I hover over this particular edge, I get a snap point. Not sure if it's quite visible to you guys, but I do get a snap point, a plus point, and I can simply select it and start drawing a circle. Okay, so I'll enter a radius of 10, and my circle is ready. Okay, I'll simply do it at the other end as well. Probably it would be more clearer this time. So see, enter, simply hover over this arc. You get a plus symbol that denotes the center of the fillet that we have just created, and simply select that point and enter the radius, and you're good to go with the circles. Okay. Now, once this is done, you can simply select the circles and then extrude it downwards to create holes. Okay, so the same operation that we performed for the top part, wherein we just selected the circle edge and then extruded it across the cylindrical profile on the top. The same operation we are doing over here, but this time I've selected two profiles. So you can do it with multiple profile selections as well. I selected both the circular profiles, and I'm just creating an extrude operation to cut material from the base plate. So I'll just give it a depth of 15, let's say, and we get two circular holes on the base plate. Now, the next step, again, I'll select these two edges, and I need to enter chamfer. So I'll just enter DM chamfer. Once again, you just cannot enter a chamfer command because that is something that would be there for 2D. You need to enter a DM chamfer command, and the chamfer distance for this particular circular profiles is 5 mm. Right? So I'll simply enter 5, hit enter, and select the two profiles and hit DM chamfer again. Give a distance of 5 and hit enter. So you get the chamfers onto the circular profiles that are there, circular holes that we just created. Okay, so we are given a 5 mm chamfer to the circular holes. Again, the command is DM chamfer, the regular chamfer command. The next part includes creation of a rib for this particular stand. Okay, so the rib would provide an extra support, of course. And for the rib, there are certain steps that would be following. So I'll again be creating a rectangular profile. And in this case, the profile would be 50 mm by 20 mm. Okay, so I'll simply enter the command rectangle. That's correct. And I can just create it. In order to lock the surface, I'll press shift. So my surface is locked now. So I'll be only drawing on this particular surface, and I can start drawing. The dimensions of the profile are 50 by 20. So 50 by 20. Okay, so you can toggle between the dimensions just by pressing tab, and once you are good to go, just hit enter. Now, again, we need to move this profile to the center of this vertical stand. So I'll be doing the same thing again. Use move, M, enter, select the profile that you want to move, hit enter again, select the base point, that's the midpoint of this profile and the midpoint of this edge. Okay. And once you have reached this step, you can simply go over here and select the extrude command. Okay. However, in this particular case, we'll not be using the regular extrude because the top profile is circular. Okay, where it needs to end is a circular or a cylindrical profile, and we just cannot give a distance to it because simply then it would not map to the circular profile. So in this case, we would be using the set limit option. Okay, so you can enter or you can execute the option simply by clicking it onto the command line or simply by hitting L enter. So this is what you can use. So simply just in the command line, press L, hit enter, and now it asks for selecting a face or body to limit the extrude. I'll just select the cylindrical surface to limit the extrude. And once I do that, you could see how it could map onto that particular cylindrical profile very easily. So in this particular case, or in such scenarios, I can use the set limit option wherein I did not give any magnitude, but I can select set limit option to be able to limit my extrusion to that particular profile. Also, with the help of this particular push-pull, the intelligent integrations that we are talking about inside BricsCAD. So let's say if I push-pull this particular surfaces of this rib that I create, okay, so as you can see, the push-pull does map to the circular profiles as well. So I did not again and again create a new rectangle or to be able to change the width. I can simply push-pull the geometry and simply extend it or trim it depending upon the requirement that I have. So I can simply do that. As of now, I'll just press escape, not be making any changes. However, this is something that you can try by yourself as well. So it will map to that cylindrical profile. Again, the set limit would always be activated as long as I've used it for the extrusion. Now, so once that's done, the next part is wherein I need to give constraints to my solid. Okay, so the creation part is almost done. Okay, now the constraint part is wherein I'd be fixing up certain entities and giving geometric and dimensional relationships to my model. How my model will behave in case if I do make certain changes to the dimensions is what constraints help me to do. Okay, so this is something that we use constraints, or we call it parameterize in BricsCAD. So the first constraint that would be applying is the fix constraint onto the back face over here. So you can also enter the command called dmfix3d, okay, or you can simply select the lock option that you can see inside the ribbon and select this particular surface to fix it. And now you can see the entities in the set are 1 and hit enter. Now this face is locked. Okay, so if you make any changes to other geometries, nothing would happen to this particular face supposedly. Okay, so this is what it means by fixing a particular plane geometry or surface. Right. The next thing that's there is assigning a radius constraint. So we'll be assigning a radius constraint to the circular holes that we have. So over here, we have the radius, okay, which creates a radius constraint for 3D entities. So you can execute it from the command line, calling the command dm radius 3D, or you can simply select the radius constraint from over here. Select the profile for which you'd want to create a radius constraint for. So let's say I'm selecting this particular hole in this case. So right now I'm just accepting the value that was there earlier, 10. I'll just hit enter. And my radius constraint is created. So this is where I get to know the constraints in the mechanical browser. Okay, in case if you are not able to see mechanical browser, right click over here, go to panels, make sure your mechanical browser is checked. So this is something that you can have it in your screen as well. So over here, the constraints that I apply are visible. So the fixed constraint is there, the radius constraint is there. You can also see, after applying the constraints, what kind of changes would happen if I do change the constraint. So you can instead of doing an actual change, you can simply in BricsCAD animate the change. So let's say if I change from 10 to 20 or 8 or 5 maybe, what kind of change would happen to my geometry? So without actually giving a new dimension or giving a new change or new parameter for the change to happen, you can see with the help of the animations. So as soon as I animate, you can see the type of change that would happen for this particular profile if I do change the dimensions. Okay, so you can do that as well. Now over here, as you could see, right, the change just occurred for one particular profile. However, I want it to occur for both of these profiles. Now, both of these profiles are of same radii. So you can either use the design intent, okay, equal radius design intent, wherein it will recognize cylinders and spheres of equal radiuses, or you can simply give another manual constraint for this. So both ways it would work. Right? So this is something that I'd leave up to you. I just want to show you the design intent functionality. So I'll select this particular option of equal radius. And now if I do animated, it would change both of this radii. Okay. So this is something that the design intent again helps me to do without actually applying a manual constraint. Now, suppose if it's a complicated geometry and you do need to apply a lot of constraints, it does help in that case, wherein you can just avoid applying irrelevant constraints to geometry. So this is something you can do. The next constraint is an angular constraint that I want to give it for the rib part. Okay. Now, because the standard ribs are not always completely rectangular, they are tapered at certain angles. So in order to achieve that particular geometry, I'll be giving an angular constraint to this particular face. Now, where do I do that from? Is I'll select this particular angle constraint, which creates an angle constraint between two 3D entities. Okay. So you select this, it would ask for the first entity. So I'll select the first entity that I want to change, select the next entity as a reference. Okay. So this is the entity that I want to, that I'll be selecting. The reason behind it is because if I do make any changes to that particular surface, since this I've kept fixed, only this particular surface would change with respect to the parameters that I assign. I'll select this particular surface. And now, if you see the angle that, the type of constraint, or the type of angular constraint that has been applied is in the Z direction. Okay, so the axis that it has taken into consideration is the Z axis. So the Z axis is something that we do not want. Okay, it does not have to revolve or rotate around the Z axis. It has to rotate along the X axis. Okay, something we need to address it. Okay, so we need the position to change across the x-axis. Okay, the surface to rotate across the x-axis and not the z-axis. So in order to change the reference, I can set a reference entity in my angular constraint. So I'll select this particular option to set a reference entity, and the reference would be any particular edge in the x direction. So I can select this particular edge or an edge from that side or any particular edge that resembles the x direction. I'll just select this particular edge in this case. Okay, now I'm not sure if you're able to see it on my screen, but now the reference has changed. It no longer revolves or rotates around the z-axis. It now is adapting to the reference entity that I select, and I can simply enter the value and my constraint is added in the mechanical browser. So you can see as soon as I select the constraint, we can see the entities between which I applied the constraints to. If we expand this, you can see planar face 1, planar face 2, and the linear edge that you are selected as a reference. Okay, so these details are present inside your mechanical browser. And if you go to your planar angle and in the expression column, if you change it, let's say to 170 degrees, okay, so you get the desired output. Now I do have an inclination or a tapered rib the way that I want it to be in my component. So this is the exact same thing that I want. So I just rest it over here. I just changed the angle from 180 to 170 with a 10-degree difference, and my rib is ready. Okay. Now, once you are reached till this portion, you need to be able to create fillets around your ribs. So in order to create fillets around your ribs, what you can do is simply select the edges of your ribs manually, or you can use a very quick approach of selection in BricsCAD. Simply just hover over to the rib portion and just go to the select option in the chord. Now, when you go to the select option in the chord, the very first option that says edges selects edges of faces or solids. So once you click it, you see all the edges of that particular rib, particular face is selected now. Okay, so this is a very easy approach of selecting multiple entities at one single point of time. Of course, you can do it manually, but this is then again a real-time saver. So I'll just select this particular edge manually, this particular edge manually, this particular edge manually over here, and then go to this particular face and select the same option. Go to select and edges. Okay, so my edges are now all selected, and now you can enter DM fillet. The radius that you want to give over here is 3 mm. Hit enter, and your fillets are ready.